Enrico Fermi, the famous physicist involved in creating the atomic bomb, he was well known for this style of calculation where you approximate things. A good example would be to approximate how many cheeseburgers it took to build the pyramids, or something ridiculous. And you try to get estimates using units and orders of magnitude, essentially the general scale of the figures, to come up with a rough calculation that will actually give you some kind of insight. And famously, before the atomic bomb actually went off, he did one of these calculations. He would always do them in his head. And he tried to figure out the power, the energy that would be released during the explosion. And he had some pieces of paper, and he sort of saw them move on the floor based on the blast. And he was very precise, his estimation of that. And so there's this idea named after him and after this calculation style, and it's called the Fermi paradox. And it basically goes like this. We have so many galaxies, and we have so many stars in each galaxy, and we expect so many planets around each star, and so on, that why aren't there aliens basically everywhere? That when we look at the numbers, the sheer scale of the universe, and we combine that with how quickly technology takes off, we should expect to see intelligent life throughout the universe. And as far as we know, as far as we've been able to measure, human beings are the only intelligent life forms in the universe. And that creates this paradox, this Fermi paradox. Basically, where is everybody? And I've been thinking about that a lot lately. And in particular, this idea of the technological explosion. If we were to create a timeline and put on there things like the invention of fire and the steam engine and the invention of electricity, or even farther back, things like the hand axe, when people used to just, or even primates used to just basically chip stones away to make primitive tools. And we create this technological timeline. And then we were to look at the difference between, say, the radio, or even electrification, and what we now call AI. Things like ChatGPT, large language models. We wouldn't be able to tell them apart. Radio and electricity and computers and AI, they're on the same line, right? You would have to kind of draw an arrow and expand it, kind of like on the map when you can't, some of the states are so small you have to just point to them with an arrow because they're not big enough to write their name across the state at the full scale. On this timeline of technology, AI and computers and electricity, they're all the same dot. And so when we imagine that out in 100 years, or let's just say 1,000 years or 1,000,000 years, the kind of technology we're going to see, it's going to be essentially unimaginable now, where we'll have things like intelligent matter, not just intelligent machines, but as Kurzweil talks about, spiritual machines. Things that, as I've talked about in one of my earlier videos, things that might be indistinguishable from what we previously called angels, or unfortunately maybe demons. What do I mean by that? Well, if we think about an AI now, it's made out of electricity, a GPU, an Intel processor that supports these language models and these things that seem intelligent or approximating intelligence. They're run on electricity. But the next generation of this technology is going to be run on optical circuits. And maybe after that, something even more exotic, spintronics or some sort of exotic matter. We've figured out how to get physics to do things, to compute. We've learned the rules and the recipes for how the natural world operates to such high precision that we can paint down lines on semiconductors with exotic materials, what we'll call wafer fabrication plant, and build these chips that then if we program them with the right software, they have intelligent behavior. They can answer questions in multiple languages on lots of different subjects and so on. So if we take that technology out, even 30 years, it's going to be running on optical circuits. And then we're going to have light essentially, in a very interesting dynamic where those photons are going to exhibit intelligent behavior, sort of intelligent circuits, intelligent light, intelligent matter. Well, when we think of a being made out of light that has intelligence and maybe even intention, a few hundred years ago, a few thousand years ago, we called those things angels. And so in some interesting way, we're building those now. And we could think of this as a metaphor and just say, well, we're using historical language to describe advanced technology. Or we could look at it the other side and say, well, it doesn't matter. We have accomplished that thing that we were talking about previously. And so this brings me back to this Fermi paradox, that we have to find an answer. We don't know why we don't see any intelligent life. And I propose that the answer, one of the simplest answers, is that we just don't recognize it. We are looking for essentially evolved primates in saucers, big heads, big eyes, no hair on their skin. If we were to take the sort of the primate evolution from, Neanderthal, Australopithecus, and all these kinds of things to the modern day human, and we just extrapolate that, we would expect to have bigger foreheads, less hair, bigger eyes, and so on. But that's a small jump, right? Go out another 100 million years. We might get things that, I've been thinking about sort of non-corporeal beings. Why do they have to have any substance at all? Maybe they're just patterns. Maybe they're just these beings made out of light that if we take the GPU, turn it into optics, get the LLM, maybe it'll escape that substrate. Maybe it'll find that it's easier to be a self-propagating waveform through space-time or something we can hardly wrap our heads around now. So with this Fermi paradox, maybe they are here, maybe they're everywhere. The ancient world certainly thought they were. And maybe it's just that our perceptual window is so narrow for practical historical reasons that we just don't see it. And maybe they're in front of us right now.